Hi. Now that we know how random walk with drift and translationary process work, we are ready to devise some simple tests that will allow us to distinguish between these two. Okay, and let's start simply with the test with no time trend. Okay, we are assuming that time series that we are analyzing can be written as yt plus 1 is equal to some alpha plus delta yt, and of course, random disturbance. This is the same random disturbance we were considering previously, right? So we're assuming that it comes from normal distribution with zero mean and constant variance. Okay, let's look at this specification. And let's think about it for a second. Can we actually estimate it? If y is GDP, I can definitely find value of GDP at some period t plus 1 and estimate it on the constant and previous value with some coefficient delta and of course error. So as you see, it's really easy to get this data. Look, usually when we have a regression, we have two different variables. In this case, we just need one, so this is going to be very easy. Okay, but even though we can estimate this, and as if you think about it, this is all we need, there is a better way of approaching whether this, in fact, in this case, we are dealing with random walk with drift. Look, first, I'm going to subtract yt from both hand sides of this equation. Right? So what am I getting? Yt plus 1 minus yt equals to alpha alpha plus delta yt minus yt plus average. Okay, I can easily replace this with simply delta yt, and over here I will have alpha. If I take common part out, plus delta minus 1 yt plus error. Okay, why I did this? Because look, if we will estimate regression that is slightly different than this one, but actually equivalent, right? I can write it in the following way. Delta yt equals to alpha plus rho times yt plus error. Okay, what do I have here? Change in y, right? Regress on constant previous value of y and error. Again, something that is very, very simple. We of course need to notice here that rho is equal to delta minus 1. Now look, every time when we actually estimate an equation, we can easily make a hypothesis that a given coefficient is equal to 0 and test it. Of course, here we will have this versus alternative hypothesis that we check in this case that rho is smaller than this. Of course, you might ask why not different than 1, but in the rho should be lower than 0. Rho should be lower than 0, definitely not high. But okay, we'll get that. Now look, if we test this hypothesis that rho is equal to 0, we test the hypothesis that delta minus 1 is equal to 0. So we test hypothesis that delta is equal exactly to 1. Or in other terms, our equation, our variable, the time path, possesses unit root. This is where this unit root that we are always talking, you were always talking about in econometrics class, comes from. If it happens to be that delta is exactly 1, what we are going to have is random walk with drift. Okay, so we've got a way of detecting if some time series is a random walk with drift. However, what if we want to know something a little different? What if we want to know if this is going to be a translationary process? Look, as it turns out, we don't need to do much. All we need to do is to modify this specification to the one with time shift. Okay, how do we do it? So now we're assuming that yt plus 1 is equal to some alpha plus delta yt. The new thing that appears over here is plus beta t, and of course, random disturbance. Look, so now, based on that equation, we will have to decide which of these coefficients should be and should not be in the equation. However, we can use similar trick. We subtract yt from both hand sides. So over here, I'm getting delta yt equal to alpha plus delta plus, I'm going to write it as rho yt, right? Because we will have again the same step as we had over here. And we remember, of course, that rho is equal to delta minus 1. And of course, now we have beta and a disturbance term. Okay, and this is the equation, again, we can easily estimate, right? What's the problem? We take changes in GDP, regress it on constant previous value of GDP and time trend. However, look, please remember what we already said about the difference between time, stationary process, and the random walk with drift. We need to now distinguish between two possible cases that might arise over here. Now look, if it happens to be, and this is our hypothesis Z, that rho is exactly 0 and beta is exactly 0, what will we have? Look, this part is gone, this is 0, this is random walk with drift. So look, here we are testing hypothesis whether this is a random is different than 0. What do we have then? Then we have translationary process. And reversion to trend. And look, based on these tests, you can actually establish whether a given variable was generated by random walk with drift or maybe by some translationary process. Look, you can estimate those equations with OLS. And let's just say that this is the first good approximation. However, as it turns out, distributions of statistics, when we examine those hypotheses, do not follow regular t-distributions. They actually follow Dicke-Wheeler distribution that we're going to discuss a little bit later, but only for practical purposes. As you will see, every software you can use to actually examine unit roots already assumes Dicke-Wheeler distribution, which actually is very convenient. However, it's good to do this first, even with a simple OLS, because it gives you a sense of how it works. Now, the second thing that I wanted to tell you is, in general, why we do unit root tests. And what does it mean that a given variable is stationary? Okay, this is not an econometrics class, so I just want to give you a very brief information on this subject. Okay, imagine two variables. One is population, and let's just say that the graph of this looks like that. And the second one is GDP. And the graph looks like this. Okay, for simplicity. Now look, if I'm going to make a regression of GDP on population, will I get an outcome that is beta that is statistically significant? Of course. Why? Both of these variables have trends. They are increasing over time. So, if we calculate mean over here, let's just say the mean is going to be here. If we calculate mean over here, it's going to be over here. If we calculate mean over here, it's going to be over here. And the same here. So look, because both of them have trends, it doesn't really matter. If there is a connection between them, you will always get statistically significant result of beta. So beta is statistically different than 0. However, it doesn't need to be the case. The thing is, here we encounter a problem of so-called spurious regression. If you take two variables that have increasing trends, or two variables that have decreasing trends, or one that has increasing and one that has decreasing, you will get always an outcome that is statistically significant. However, this is something we call spurious regression. Spurious regression means that it doesn't mean anything. Because we can only regress variables that are stationary. Stationary will allow us to get from this situation to a situation in which we can actually make a regression that will tell us something meaningful. However, depending on the nature of a data generating process, so whether it is a random walk with drift, or for example, a translationary process, we should do it in a different way. Generally, idea goes like this. If we have random walk process, right, with drift, it works like this. Now, look, if I'm going to subtract yt from both sides, we know that this is random walk with drift. What do I get? I get that y delta yt is equal to alpha plus et. And look now, can I use this variable? Can I use delta yt instead of using yt plus 1, yt plus 2? Can I use deltas? Yes. How? Well, this is a constant. So it has a constant mean, constant standard deviation. This is normally distributed with zero mean and constant variance. Definitely, this is the way to go. So look, if it turns out that a given variable is represented by random walk with drift, the best way to avoid the problem of spurious regression is by taking first differences. Because first differences will fulfill the conditions that we need. We have constant mean, constant variance. Now, how about if we've got translationary process? Now, will the same trick work? Look, if we've got translationary process, again, if I'm subtracting yt from both sides, have I eliminated the problem of spurious regression, which is increasing mean or variance? I haven't. Look, we still have a time trend, right? So mean value of y is increasing over time. So this is actually the very opposite of stationarity. We've got a mean that is ever growing, right? How will we fix that? Well, let's go back to this case. Let's just say that now we know that those processes over here are translationary. How will we fix it? We would have GDP t equals alpha plus some, let's call it gamma of t. What can we do to eliminate non-stationarity? Very simple. We add beta t to our equation, and this will, suck in all the deterministic trend, and we will get meaningful relationship between these two variables. So as you see, depending on what is the actual nature of the underlying time series, we should use different method of transforming the data before estimations or modifying a method of estimation. Okay, you will be practicing this a lot during workshops, and you will have to do all of it, use all of it in your paper. So in the next couple of videos, you're going to see how to do it, and I'm also going to explain